And I'm recording. Good afternoon. My name's Julie Bloomquist, and I'm the moderator today for the PASS Database Administration Virtual Group. Today, we're going to have part 2 of working with very large tables like a pro in SQL Server. Our speaker is, again, Guy Glancer. This presentation is being recorded. It will be posted on the Virtual DBA chapter archive page starting tomorrow. We are part of the PASS organization. There's PASS BA Day coming up in San Diego. You could register, and there's still a discounted rate of $475. The PASS Summit is coming up October 31st to November 3rd in Seattle, Washington. And if you register with the code VC15FPS6, you'll receive a $150 savings. Like I said, we are one of the virtual chapters. There's a large number of them. You would just go to your PASS account and associate it with another virtual group or even a physical chapter. You will only receive emails about the meetings that are coming up. 2017 PASS Directors at Large elections are opening up. There's 3 seats, and you can go. If you're interested, you can contact the board at thegovernance@pass.org. PASS is looking for visionaries to serve on the PASS board. You can also contact them about that possibility. We are also looking for nominations for the Passion Award. Please submit that between July 8th and September 1st. These are for our outstanding individuals who volunteer and who are passionate about PASS and SQL Server. SQL Saturdays are one-day mini conferences, and these are the ones that are upcoming around the world. Usually there's just a nominal fee to cover the lunch. So here again, you can join a local in-person chapter, or you can associate your account with the physical chapters. There are a large number of volunteering opportunities with PASS, and you can also submit nominations for the volunteer recognition for the Outstanding Volunteer Award. If you discovered the DBA virtual chapter on YouTube, that's great, but we would love you to become a PASS member. It's free, and like I said, you will only get the emails about our meetings, and you'll be able to download the supplemental materials, for many of the scripts. Again, here is how you can stay connected with PASS. And once again, we have Guy Glancer. He's the Data Platform MVP. He's the leader of the Israeli PASS local group and is also the CEO and founder of Madeira Data Solutions. His career has been focused on the Microsoft Data Platform for over 20 years, performing various database roles as either an on-site DBA, an external consultant, or a speaker. Guy's involved in many activities on the Microsoft Data Platform community. He occasionally speaks at community events such as the PASS Summit, SQL Bits, SQL Saturday, and user groups around the world. He co-hosts the SQL Server Radio podcast. So I'm going to change. Oh, here you go, Guy. Okay, Guy, you should be presenting, and I do see your slide deck.
Excellent. Thank you, Julie. And hello, everyone. So my name is Guy, and this is part 2 of working with very large tables like a pro in SQL Server 2016. If you didn't attend the first part, so let me just say a few things. One of them is about the SQL Server Radio. So if you haven't heard about SQL Server Radio yet, SQL Server Radio podcast is something that I'm really proud of. Me and Matan Youngman, we talk about SQL Server, community, events, professional opportunities, projects that we are involved. We have some people that we interview once in a while. So it's really nice if you're interested in SQL Server, and I guess you are, otherwise you wouldn't be here. Tune into SQLServerRadio.com. From the previous part of this session, I got some really great feedback. Things like, excellent, this was very helpful. I look forward to the continuation of this topic, which is now. I enjoyed and learned from it. Thanks, demos, you made things, some thoughts on partitioning and more like this. So it's really, thank you very much for the feedback. It's really warming, and it gives me motivation to do these things more, to speak to people about topics and to teach people to get this great feedback. So thank you very much. And I want to go quickly to do a recap of what we did in the first part, and then move on to the second part today. So the agenda was to talk about very large tables in SQL Server, how we work with them, how we do it like a pro, how we do it efficiently, and to talk about some new features in SQL Server 2016 and also 2014 that enable us to do it better. We talked about what is a very large table. Is this a very large table, or maybe this one? The answer, of course, is always, it depends. And my answer is a very large table is one that requires special care, meaning if you need to do things in a different way, the way you manage the table, the way you operate your different processes, maintenance, for example, in your database, when the table becomes large, the point that you need to do things in a different way, this means it's a very large table, at least for you. So for one person in one environment, a 5 gig table might be considered a very large table. For another person in another environment, maybe just a 5 terabyte table will be considered a very large table. So it really depends. And when I talk about very large tables, specifically in this demo, we have the page views table. What I mean here is a table that has some kind of ever-increasing column, like a datetime column. It's a log table or an events table. In this case, it's the page views, and it gets lots of inserts. Rows are inserted very quickly into the table and becomes larger and larger all the time. And it has some challenges in querying it and managing and maintaining this table. So in this case, we're going to have the page views table. When we talk about working with very large tables, I talk about 4 aspects of working with it. One is to manage the table, query the table, update it. And when I say update, I specifically mean loading data into the table. In most cases, those tables are insert only. There are no updates. Sometimes there are, but I'm going to talk about the inserts in this case, and also how to maintain the table. We talked about managing the table in the previous session, and we specifically talked about table partitioning. So it would be very wise to partition your very large table. It facilitates data archiving scenarios. This is the main reason for partitioning. If you want to archive all data from your very large table, either putting the data aside to a different location or just delete all data, it will be much easier to do it with partitioning, with the operations of merge, split, and switch partitions. And then you can just switch, let's say, the last day, the oldest day in your table, assuming you have a partition per day, it would be just a metadata operation, no resources, no downtime, no performance issues, very easy to do. You can spread partitions between different storage tiers. If you have, for example, slower disks and faster disks, you can put your recent partitions, your hot data, on the faster disks and other partitions on slower disks, because each partition potentially can be located on a different file group. So this is another thing you can do. It also improves table maintenance. We will talk about maintenance today. We'll see some features related to partitioning that you can use for table maintenance. And I also said that partitioning does not necessarily improve query performance. And I got some feedback about that. So yes, partitioning was originally designed to facilitate management of the table and maintenance of the table, not to improve query performance. And in some cases, you might get improvements to query performance. In some other cases, you might even degrade performance when you use partitioning. It really depends on the query, how you write the query, and your the table design, how it is structured. But in most cases, at least from my experience, you will not get query performance improvements. And I see a lot of clients, a lot of people implement partitioning, and then they are disappointed because they don't get the query performance they expect. Well, you shouldn't expect query performance improvements by using partitioning. You should expect great improvements in how to manage and maintain your table, and I'm going to show that later. One of them, of course, is the sliding window, the archiving scenario that I talked about earlier. We also talked about stretching tables to the cloud using the new StretchDB stretch table feature in SQL Server 2016. And what this means is that you can take a table, enable it for stretch table, StretchDB, and it will create for you, or you can create in advance, a database, an Azure SQL database in the cloud in Azure, and then SQL Server will take the old data based on your policy, on your definition of what all data means. It will take the old data and asynchronously transfer it to the cloud, to the database in the cloud, and then you have only the recent data, the hot data locally, and the cold data in the cloud. But the nice thing about it is it's completely transparent to the application. So you can query your table as if it was all locally, but assuming that most of the time you just want to access the hot data, you're not going to feel the difference. Once in a while, if you need to access cold data, it's going to take it from the cloud, so you have some latency, but it's transparent and it works very well, very easy to implement it. So in order to set up the StretchDB feature, you need to run the Stretch Database Advisor first. You don't need to, but it's recommended. This will tell you what tables are candidates for Stretch table, and if you have any limitations. You need to enable remote data archive at the instance level. You need to create, of course, the Azure server in the cloud, or choose an already existing server. You need to create a firewall rule to allow access to your SQL server to the cloud. You need to create a database master key locally. This master key will encrypt the credentials to access the Azure SQL database, the server. And then you, of course, create a database code credential to access the server. You need to enable remote data archive at the database level as well. Optionally, you can create a filter function. The filter function will tell SQL Server what data is considered cold, what data should be moved to the cloud. If you don't create a filter function, then the entire table will be stretched into the cloud. It's also an option. And then you enable remote data archive at the table level, and you're on. You can go with StretchDB. So that was the management part from last time. We also talked about querying the table, and specifically the ascending key problem. When I talk about the ascending key problem, what I mean is we have this ever increasing daytime column, and let's say the table contains 7 years of data, and most of the time users only query the last week. So we have an issue with statistics, because at some point in time statistics get updated, so everything works well, but based on the default threshold of SQL Server before 2016, it was 20%. You need to have 20% of the rows modified before you have auto-update statistics in the database by default. And let's say you have a 1 billion rows table, you need to have 200 million rows modified before you have an update statistics. This might take a while. So after a week, according to statistics, in the last week, there are no rows at all because it's not updated. It was only updated last week. And when users query the table for the last week, the optimizer gets it wrong. It estimates 0 rows in the last week, while in reality there are maybe 1 million rows or whatever. And then you get poor plans, poor performance, and that's a very common problem. We talked about some solutions. One of them is to update statistics manually. Don't rely on the auto-update mechanism of SQL Server. You can update statistics manually. You can have a job that does this daily, for example. This might be a problem if you want to do it with a full scan and the table is really very large. It might be too heavy, might take too much time or too many resources from the server. If you do it with a sample and not a full scan, it might not be accurate enough. On the other hand, it might work. So that's a viable solution. You can use before 2016, you can use trace flag 2371. This changes the behavior, the threshold of 20%, to a dynamic threshold that gets lower as the table gets larger. So for very large tables, the percentage will be much lower, and the frequency of how to update statistics will be much higher. In 2016, this is the default behavior, so you don't need to use this trace flag anymore. Before 2016, I recommend to use this trace flag always. I think that in all cases, this works better than the default behavior of 20%. Since 2014, we have a new cardinality estimator, which is the component within the optimizer that estimates the number of rows in the plan, in the query, based on the statistics. And it was rewritten in 2014. It was also improved in 2016. So one of the things that we improved is the ascending key problem. So now the new cardinality estimator will recognize the pattern of the ever-increasing column, and it will not just rely on statistics alone. It will try to estimate how many rows are in the last week, even if the statistics says there are 0 rows. Okay, so it will not be as accurate as an updated statistics, but it will be much better than just saying 0. So that's another thing that you can get just out of the box when you upgrade to SQL Server 2014 or 2016. I also said in the last session, and this is important, this new cardinality estimator has some drawbacks. In some cases, you might get a worse plan than before. So you have to be careful. You have to, when you change the compatibility level of your database to 2014 or 2016, you have to monitor your query's performance and make sure that nothing bad happens. And if something bad happens, then of course you need to either use a trace flag to revert to the previous cardinality estimator, or optimize the query and make sure that it runs okay. We talked about filter statistics. This is something that exists since, I think, SQL Server 2008. So what you can do, you can dynamically create a filter statistics only on the last week. So this will run much faster. It will be much more accurate. And before 2016, as long as you use hard-coded values, SQL Server can recognize that the filter statistics covers the range of values you need, and it will use the filter statistics and will give you much better estimates. In 2016, it's even better. You don't have to use hard-coded values. You can use non-deterministic expressions. You can use parameters, and in all those cases, SQL Server now in 2016 can use filter statistics, which is a great improvement. Of course, you need to maintain this solution. You have to create a job, for example, that runs daily, drops the previous filter statistics and create a new one for the last week, and so on. Okay, but this is it requires some development and maintenance, but it works very well. It's a very good solution. And I think this is where we stopped the last time, and we'll continue to talk about incremental statistics, which is a new feature since 2014. And then we'll move on to the other topics. Are there any questions so far, Julie? Julie?
Hold on. Technically, partitioning can improve performance if the partition key column is used in the where clause. That's from Tim Cartwright.
Yeah, so again, I know in some cases it can improve performance. I'm not saying it will never improve performance. I'm just, again, from my experience, in many cases, clients are disappointed because all they expect is to improve query performance, and they don't get the improvements they expect. This is not what partitioning was designed for originally.
That's it for questions.
Okay, great. So this was just the recap of the previous session. Now let's go to the demo. Okay, so in the demo, what I'm going to do now is to simulate again the problem. I'm going to delete rows from the last week. Then I'm going to update statistics. But now the new feature is this. When I update statistics, or when I create statistics manually, I can add incremental equals on. Now this is an incremental statistics. And what this means, let me update. What this means is that now statistics is per partition. Okay, so this is another great benefit of partitioning. Again, not query performance improvement, but well, you know, it will result in query performance. But the feature now is that statistics is now updated per partition. It's still a one single statistics object for the entire table. You don't have now a single a separate statistics object for each partition. It's just one object for the entire table. But there are two things that now are changed. One of them is that statistics can be updated per partition, so you don't have to update the entire table. You can only update a specific partition, which will be a much faster operation. But it will merge the data for that partition with the entire statistics of the table. The other thing is that the threshold of 20%, for example, now operates on the partition level. So as soon as you have 20% of the rows in a specific partition that are modified, you will have auto update statistics for that partition. Okay, show you now. We have now the statistics, and it's updated as of last week because I deleted rows from the last week. Okay, and now when I insert rows in the last week, so we go back into the future. Previously, in the previous session, we saw that it didn't trigger update statistics because we had that 20% threshold. If we look now, I run this query all the time, give me the rows from the last week. Okay, if we look at the execution plan, then now we see a good estimation here, okay, compared to the actual number of rows. Whereas before we saw just one row because statistics weren't updated. And the reason we have good estimation now is because statistics is now updated. We can see that the last row is today. Okay, so now the threshold of 20% is per partition, and because we inserted rows for the last week, we actually inserted a lot of rows to the last 7 partitions, and within each partition, which was originally empty, of course we exceeded the threshold of 20%, so we updated all those partitions, but only those partitions, not the entire table. So it's much more accurate now. If we insert just, for example, 3 hours from yesterday, this is what I'm doing now. So if you remember the numbers more or less, you can see that the number here has increased, but the number here hasn't changed. Okay, and the reason is that 3 hours of data in this case are not enough to update the statistics to cross the threshold of 20%. If we look now at all the partitions in the table, so these are all the partitions. We have 181 partitions, and the number of rows in each one. And what I want to show you is that partition 178 is yesterday, right? Yes. 179 is today, and this is tomorrow. Okay. Okay. So for example, what I can do with incremental statistics is to only update statistics for yesterday. And this is the syntax for the specific partitions. Notice that you have to write with resample because you can't change the sample rate for a specific partition because it's part of the single statistics object. So what this statement does, it now updates statistics manually for only a single partition. Okay, so even if you don't want to rely on the auto update statistics when you use incremental partitioning, you can have now, let's say, a daily job that updates only the recent partitions with full scan. If the original sample is full scan, this will be much more faster and accurate. So now we can see that, well, we can't see it actually, but it was updated. And the query now should have a better estimation. Yes, a bit better than before. It was 191, now it's 193. And last thing, when you create statistics, when you can change the property of the database to set auto create statistics on with incremental equals on. Okay, so you can instruct the database that when it automatically creates statistics on a partition table, it will create them as incremental statistics. So this is to summarize the all the options to improve query performance regarding the ascending key problem. And okay, so the next section is data load. Do we have any questions about this?
No questions.
Okay, great. So the next section is the data load, and let's look at, here it is. So what I'm going to do now, I'm going to simulate inserts into the table. I'm going to do it 1,000,000 times, okay? So I'm going to begin a transaction, insert a single row into the table, the page views table, then commit a transaction and do it again and again and again. Let's run this. And I want to look at several things. First, let's look at perf1, performance monitor. And I want to look at SQL statistics batch requests per second. This will give me the throughput, how many batch requests per second, and databases. We have log flashes per second. Of course, I need a very large table demo database. Okay, so this is the let me okay. Is the log flash per second and no batch request per second. Can't see it. Okay, that's better now. So batch requests per second, we see something like 2,000 batch requests per second. Okay, and if we look at something else, I want to look at the weight statistics. So what I'm going to do here, this statement clears the OS weight stats DMV. Okay, and then I'm going to run this select statement. It selects from DM's OS weight stats and filters out all the non-interesting weight types. I give it the top weights on the server. So we can see that by far we have the right log weight type more than anything else on the server right now. Okay, and what the right log weight type means is that SQL Server, when we commit the transaction, it has to take the transaction log content from the log buffer and flush it into the transaction log file on disk. And this is when we have the right log wait time. This creates some latency. We have to wait for it to finish writing to the transaction log file on disk. And this is the main problem. When we have a lot of insert statements, a lot of inserts into the table, like in this case, like in many cases, then we're going to have a lot of write log waits, and this will create some latency, and this will affect, of course, the throughput, the batch requests per second that we can have. If we want to increase the throughput, we need to see how we can increase the load. There are all kinds of ways to do it. One of them, let me just stop this. Okay, so one of the options, yes, the right log wait type. One of the options to improve it is by using delayed durability. This is a new feature in SQL 7 2014. And let's talk about it for a few minutes. Delayed durability talks about the durability of transactions. So with transactions, we have 4 properties: atomicity, consistency, isolation, durability. Durability means that when you commit a transaction, SQL Server will guarantee that the content of the transaction is durable on disk. It's persisted. So if something goes wrong right after you get a commit, you're okay. The transaction is safe. When SQL Server does recovery and starts up again, it will roll the transaction forward, and you'll have it, and you will not lose anything. So this is a durability. When we have fully durable transactions before SQL Server 2014, here is what's going on. We have a request, an insert, an update, whatever. We issue the request, let's say an insert, and what happens is we update the relevant data page in the buffer pool, and we also write a transaction log entry into the transaction log buffer in memory first. Okay, now this is in memory, as soon as we write a commit, we first need to flush the transaction log buffer into the transaction log file, and then we have the write log wait type, and only then we can get a commit. Okay, so let's say we have another statement, it's in the buffer pool, it's in the buffer, we issue a commit statement. This the content of the transaction log buffer will flush into this with the write log wait type. We get a commit. Third time, write log with a commit, and then at some point in time, we have the checkpoint process, which will flush all the dirty pages from the buffer pool to the data file, but this is a different process. Okay, so this is how a fully durable transaction performs. With delayed durability, okay, if we have transaction now that has a delayed durability feature enabled, what happens is we issue a statement, it's in the buffer pool, it's in the transactional buffer, and we get a commit already. So we get a commit of the transaction, and this means that locks are released and the transaction is completed, committed. We can move on before the transaction log entry is persisted on disk, okay, because it's delayed. Okay, so now we have a different transaction, another commit, a different transaction, another commit. At some point in time, for example, when the transaction log buffers fills up, okay, so we have a checkpoint, yes. At some point in time, we will have a flush of the entire transaction log buffer into the transaction log file, but this will happen asynchronously. No session will have to wait for the write log wait type, okay? No session waits for this because we get a commit instantly. So this is how delayed durability transactions work. When does the log buffer, when is it flushed to disk? So one option is if there is, even if my transaction is delayed durable, if there is another fully durable transaction in the same database, as soon as that transaction commits, the transaction log buffer has to flush into this. This includes my data, my entries. Okay, so my transaction will also be flushed to the disk. We can manually issue this system store procedure sys_sp flush log to instruct SQL Server to flush the contents of the log to disk. If the log buffer fills up, then of course we have to make room for more transactions. It will have to flush to disk. The size of the transaction log buffer is 60K per database. Okay, so as soon as this 60K buffer is filled up, it will flush into disk. And every few milliseconds, if you have an idle server that does nothing, okay, so the transaction log buffer doesn't fill up, every few milliseconds, just in case Microsoft added this option to flush the contents of the log buffer every few milliseconds. So in a real production environment, this doesn't make any difference because you have transactions running all the time. Transaction log of 60K will, in most cases, will fill up before the few milliseconds threshold. If you are doing some tests on your laptop, like I'm doing in this case, then you might just run a single transaction, and then you will not understand what's going on, why the transactions are flushed into this. This is because the few milliseconds threshold. Okay, so it will happen regardless of the number of transactions. You can control delayed durability at the database level. It is either disabled, which is the default for backward compatibility. You can change it to allowed, meaning that you can control at the transaction level in this database which one is delayed, which one is not, or you can say that delayed durability is forced at the database level, meaning all transactions in that database are now delayed. If database is allowed, then of course you can choose which transactions are committed with delayed durability. It's part of the commit statement. I will show that in the demo in a minute. And also, if you work with memory optimized tables in memory OLTP, then you can also control it at atomic block, the natively compiled procedure. Some transactions will always be fully durable, even if you work with delayed durability. For example, transactions perform operations against CDC or change tracking tables. So those tables will always be, transactions against those tables will always be fully durable. If you have cross-database transactions or cross-server distributed transactions, those will always be fully durable. And some features apply only once the transactions are fully durable on this. So for example, transactional replication. Transactions will be replicated to subscribers only after they are made durable. So as long as they are in the log buffer, even if you get a commit in the publisher, they will not be transferred to the subscribers. Same goes for log backup. Okay, so the backup operation will only back up the content of the transactions in the transaction log file. It will not read transactions from the log buffer. So only as soon as the transaction is durable, you will be able to back up those transactions. Same for log shipping, because of course log shipping is based on log backups. And what are the benefits of using delayed durability? You get less round trips to the log file on disk. Okay, so you only go once in a while, once the transaction log buffer is filled up, for example. This might be a great benefit. You get less write log waits and less latency, of course. Shorter transactions, you don't have to wait for the commit. Commit is instant, which means logs are released earlier, so you get better concurrency. You get less blocking of sessions. And of course, the result is better throughput. Last thing is you have to remember that you might lose data, of course. So this is not right for every table. If you have a table that you must have consistency and you must have all the data durable, then of course this is not a viable solution. But there are many cases of, again, all kinds of log tables, tables that you can afford losing some data sometime, assuming that you'll have most data most of the time. Then this can be a great feature for those tables, because most of the time, all of the time actually, you'll get much better throughput, much better performance of your updates and inserts, while you have the risk of losing data maybe at some point. So it might be relevant for some cases, but of course you need to consider if it's okay or not. Let's go back to the demo. So now I'm going to alter the database and set delayed durability to allowed. And I'm going to do the same thing as before. Okay, so I'll issue insert statements, one per transaction. And of course, now with the commit transaction, I add this. So this is the new feature in 2014, with delayed durability equals on. Okay, so let's run it. Let's go back to perfmon. So now we can see that instead of, I think it was 2,000, we are at more than 3,000. Okay, so it's more than 50% improvement, and the percentage of improvement will of course depend on the size of your transactions, the rate of your transactions, and stuff like that. So it can be even much more than 50%, but we can see clearly that we have an improvement of the throughput, and the number of log flushes per second. Where is it? Here. Okay, so this gives me how many times the log was flushed to disk per second. Before, in the previous example, when we had delayed durability turned off, the number of log flushes per second was exactly the same graph as the throughput, the batch request per second, because each batch request, in my case, each transaction, had to be flushed to disk. This is the original behavior of SQL Server. But now we can see that we have much less log flushes per second and much more batch requests per second. Okay, so we got a much better throughput. And if we go back to the wait stats, so let's do this again. Okay, let it accumulate for some time, and we run this query again. So now we don't see the wait log at all. Okay, we can do it again. The write log, sorry, we don't see the write log anywhere in here. We have some other wait types, but they are not very important. So no more write log. We get much less latency, much better throughput, thanks to delayed durability. Let's roll back. Yeah, stop first, roll back. Okay, we don't need this, we don't need this. We can close this, and we're back here. Okay, questions about this?
Yep. So is the incremental option enterprise edition only?
The incremental statistics, I guess. Well, partitioning is enterprise only, so it's part of partitioning. You can't use incremental statistics without partitioning. In SQL Server 2016 Service Pack 1, many enterprise edition features are now available in standard edition. One of them is partitioning, which means you can also use incremental statistics.
Great. And Mark Mills mentioned that he sees where this seems to be applicable to both large tables and small.
Sorry, what seems to be applicable?
I guess what you were doing in this last section.
Oh, about delay durability.
Yeah.
Yeah, that's true. Of course, delay durability can affect small tables as well. The important thing here is the rate, the velocity, how fast you insert data. It doesn't matter how large the table is right now. If you insert data very fast, you have lots of inserts, lots of transactions, then you want to be able to increase the throughput. One of the options, if you can afford it, if you can afford losing data, is to use delay durability. Yes.
And that's it for questions.
Okay, great. So the last topic, the last aspect of working with very large tables is maintenance. Okay, so problem number 3 we have is index rebuilds. We need to rebuild our indexes on a very large table. It might take a very long time. So before SQL 7 2014, we could rebuild all partitions offline. Okay, meaning we have the table is kind of a downtime of the table, or the index that we rebuild. We cannot access the index while we rebuild it, and it will take a while because it's a very large table. We can rebuild all partitions online, okay, which means we can access the index during the rebuild operation. It will take more time, it will take more resources, but we have better concurrency. We don't have to wait until the index is completely rebuilt. We can use the index while we are rebuilding it. We could also rebuild a specific partition offline, which is a great feature because, again, if we have a very large table containing 7 years of data, probably the old data does not change. Only recent data is inserted or updated, and there is no reason to rebuild the entire table all the time. We can only rebuild the recent partitions, but we could only do it offline. One of the new features in SQL Server 2014 is that now we are able to rebuild a specific partition online, okay, which makes sense, but we couldn't do it before. Another thing we can do since 2014 is to wait at low priority when we rebuild an index online or when we switch a partition. I will show that in a minute. Let's start with the rebuild indexes. So this is how we do an index rebuild. Okay, I alter the clustered index in this case. I rebuild partition all partitions online equals off. This is something I could do, of course, before 2014. I have here, I think it's this one. Index rebuild. Did I run it? Oh, okay. So I have all the logs. Let me make sure it's the right one. Yes. Okay. So I rebuilt the entire index offline. Now I can specify online equals on, still partitions equals all. So now I rebuild the entire table online. Okay, so this will take more time because it has to maintain the index while it's rebuilding it. And if there is concurrency, in this case there is not concurrency even, but if there is concurrency, there is load on the server, then it will take some more time. But eventually it will complete, and it's an online operation. And we can rebuild a specific partition, which is going to be much faster because it's just a single partition, but only offline. Again, those are the things we could do before SQL 7 2014. So you see, it's much faster. Okay, it's like no time. So again, one thing we can do since SQL 7 2014 is we can rebuild a specific partition online. Okay, so again, it's a bit longer, but still, because it's a single partition, it's nothing compared to the entire table, assuming it's a very large table. Okay, so this is one new feature. Now, the next new feature, let me start with the presentation, is to wait at low priority. And what this means, let me go to the, yes. So I'm going to trade it here, and then it will be more clear when you can go to the demo. So before 2014, when we issue statements, commands against the SQL, we have a normal queue. We have a queue of statements, of tasks that needs to be run on schedulers, on CPUs. And for example, the first session runs an insert statement. It will enter into the queue, and then because the queue is currently empty, it will go into the scheduler, the CPU, in order to perform the insert. Now it's running. In the meanwhile, another session tries to rebuild an index online. It will go into the queue. Now it has to wait. Yes, it's online, but in order to begin the operation, it has to take a shared lock on the table, and it cannot take a shared lock while there's an insert running. So it has to wait while the current insert statement will end before it can start the operation. And then maybe there is another insert statement that now waits in the same queue behind the online index rebuild. Okay, so the next insert statement is also blocked right now. Although if there wasn't an online index rebuild, the next insert statement could run, okay, because there is no reason that two insert statements run in parallel. They can run in parallel, but because there is currently in the queue an online index rebuild, the insert waits behind the online index rebuild. So only when the first insert completes, the online index rebuild can start. The insert can, of course, now work in parallel to the online index rebuild, or maybe the online index rebuild has already completed, so there is no issue now. But the problem is that the second insert has to wait to the online index rebuild to start, and it cannot start right away. Okay. Now, in 2014, we have this new feature, wait at low priority. So we can specify that when we rebuild an online index, or when we switch a partition, in both cases, we can wait at low priority, and then we have a separate queue for low priority tasks. Again, and those are rebuild online indexes and switch partition tasks. So now the first insert goes into the normal queue and starts running. When the online index rebuild comes along, it goes to the low priority queue. It has to wait, of course, because the current insert statement is still running. Now the second insert goes into the normal queue, and since there is no reason it can't start, it will run in parallel to the first insert statement. So both of them now can execute. The online index rebuild still waits because it's low priority. So it now has to wait for both insert statements. The first completes, the second completes, and only now the online index rebuild can start. Okay. So if we don't want our online index rebuild operation to interfere with our normal workload, we can specify that it waits at low priority. Now let me go backward. We still need to specify what happens. So how much time the index rebuild will have to wait at low priority, and what happens when this time is over. Okay, so there are three options. If this time is over, the index rebuild can continue to wait at normal priority, so it will move from the low priority queue to the normal queue at this time. It can abort the operation, abort itself, okay, stop trying to rebuild the index, let's try again tomorrow, something like that. Or after a few minutes, we can tell it to kill all the blockers, kill all other sessions that currently are blocking it, and start the operation. Okay, so those are three options. Let's go to the demo. So the demo goes like this. We start with session 1. Okay, so in session 1, we begin transaction and we do an insert. This is the first insert. And if I go here, I don't see nothing. Okay, because it's not blocked yet. Now, let's go. Yes, this is one. Okay, so I now rebuild the index online, a specific partition in this case. Okay, it's online, wait at low priority. Now I need to specify the max duration in minutes. So I will wait 1 minute and abort after wait. Why do I do after 1 minute if I'm still waiting? Okay, so this is none, meaning go to the normal queue and continue to wait at normal priority. Okay, so let's run this one. And now we have session 2, which is another insert. This is the second insert. Okay, I'm not in the right database. Let's make sure I start a transaction in the right database. Perform the insert. Okay, now let's see what we see here. Okay, so now just want to show you that the online rebuild index is 56. Okay, and now session 56 waits at low priority. So we have a new wait type. Okay, several new wait types actually. We see that it waits at low priority. It waits for both sessions 58 and 59, which are the two insert statements. Okay, because now they are both running in parallel, and now it waits at low priority. And after 1 minute, which should be over now. Okay, so now the wait type has changed because it moved into the normal priority queue. Okay, and continues to wait. As soon as we commit the transactions, first one and the second one, only now it can complete the online index rebuild. And now, of course, we'll see here nothing. Okay, so this is one option. The second option, let's do this again. Session 1, first insert, then we have the index rebuild. This time I'm going to specify abort after wait self, meaning I will wait 1 minute, and after 1 minute I will abort the operation. I will stop trying to rebuild the index, and then session 2 performs the second insert. If we look here, you see the same as before. Okay, so again we have two inserts that are running, no problem, they're not blocked by anything, but our session 56 is blocked. It waits at low priority. And now what we're going to see after 1 minute is that this session 56, this one, okay, will stop. It will kill itself. It'll abort the operation. So let's wait a few more seconds. And then, of course, the other inserts can continue to do whatever they want. They're not blocked anyway. If we look at this again, I think I had a time here. No, I don't have the time. Okay. Lock request timeout period exceeded. Okay, this is the error you're going to get. It's just like lock timeout, and it aborts itself. And the last thing, let's do a commit. And a commit here. Okay, so the last one, again, session 1, first insert, then rebuild the index. Let me first run it, okay, to get it going. Abort after wait blockers equals blockers. So now after 1 minute, it will kill all other sessions blocking it. In this case, the other two insert statements. Okay, let's now do session 2. And I want to show you what happens. No commit, sorry. What happens when they are aborted? So again, they're waiting at low priority. So after 1 minute, the online index rebuild will be able to start and complete the operation. And I want to show you what happens to the other two, how it looks like. Okay. So in this case, there is no statement running. Okay. The insert was completed successfully. The transaction is currently active, but no statement is running. So we'll not get any error message or any notification in session 1 and session 2 about the being aborted. But what we will see, okay, so it's done, and this is done. Okay, this is completed now, the online index rebuild. Session 1 at this point doesn't know anything. If we try to commit the transaction, we will get this error, okay, because we have been rolled back. And same for session 2. It was rolled back, no transaction. The insert was rolled back, nothing happened. Okay, so this is how it works. And okay, we saw all this. Let's go quickly through the demo. Okay, so before the summary, questions about online index rebuild or wait at low priority or anything else?
Well, something else. What considerations for the rebuild is an always-on environment before 2016?
The always-on before 2016. considerations for the rebuild. I'm not sure I understand the question. What is the difference regarding always on? If you want to, well, you need to rebuild your indexes. You need to do it just as well in your primary replica in an always on database. Of course, that all the maintenance, all the rebuild operations will be propagated to the secondaries as well. But I'm not sure what the purpose of the question. I don't see a difference in the considerations when you rebuild your indexes or when you do it online or offline with always on. So sorry, maybe I'm missing something in this question.
Okay, the next one is, does the delay durability work with in-memory database / tables?
Good question. I think yes. I'm not 100% sure. Sorry, I need to check this. I think yeah. I think that you can use delay durability with in-memory tables.
And that's it.
Okay, so great. Let me summarize. So we talked about what a very large table is. And again, in my opinion, this means you need to give a special care to this table. As long as you do the same things with your table, they're not considered very large. What it means to work with very large table, we talked about managing the table, specifically partitioning, and also stretching the table to the cloud with the new feature in SQL Server 2016. We talked about the ascending key problem, how to improve query performance with things like filtered statistics and incremental statistics, and the new cadenity estimator since SQL Server 2014, and some other things. We talked about how to improve data loads, the rate of inserts using delay durability to improve the throughput. And of course, you have the risk of losing data. And also how to improve the maintenance of the table by rebuilding single partitions online. And also by specifying that you wait at low priority when you rebuild those partitions to not interfere with your regular workload. What it means to work like a pro. So again, those are the how to solve the ascending key problem, how to solve the write log problem with delayed durability, the index rebuild, and the wait at low priority. And the new features we talked about in SQL Server 2016 are stretch database, the new cadenity estimator. It's a new feature since SQL Server 2014. It has some great improvements, and again, in some cases it might be dangerous. You have to monitor and be careful about the implications of enabling it. You have incremental statistics in the partition table. You have delay durability, and we have the online indexing enhancements we just talked about since 2014. Some other things you might want to explore that I didn't cover in this session. So one of them is compressed data. If you have a very large table and it consumes a lot of disk space and also space in memory and also I/O, you can improve all of that by compressing the data potentially, and this will reduce dramatically the space acquired by the table and its indexes, and also improve the amount of I/O against the table. There are all kinds of things you can do optimizing parallelism. Okay, so when you work with a partition table, a very large table, you can improve how SQL Server produces parallel plans and how it executes them at runtime. There are many things you can do here. I didn't cover any of that in this presentation. What I can recommend is to follow Adam Mechanic, who is an expert in this field. Watch his recorded sessions or follow his blog. He writes and talks a lot about parallelism, and he's a master in this field. You can consider maybe using a lower isolation level. So if you have a concurrency problem against this table, you have many apdates, then you might, in some cases, work with read uncommitted or the no lock query locking hint, which might be good enough, although it has some implications. Or maybe you can use read committed snapshot and improve concurrency. Of course, this means you will have more overhead on TempDB, so you have to monitor and see if it's good for your environment. And if it's a data warehouse and it's a star schema structure and you have a very large fact table, then using column store indexes can really speed up your aggregations and star schema queries. So consider using that. And that's it. You have my contact information here. You can follow my blog. There is already a post on my blog, which is here, which summarizes the session. It already contains a link an embedded link to the recording of the previous session. As soon as the recording of this session will go live, I will update the blog post and put it there as well. And you can download all the materials, the presentation and the demos from that blog post as well. So it's all there. And thank you very much. Are there any questions?
There's one more question. What other operations beside index rebuilds can use low priority? The question's about like maybe update statistics or backups.
So no, only two types of statements, online index rebuild, and it's only online. You cannot use it with offline, only online index rebuild. And the other statement is switch partition. Those are the only two statements that you can use with low priority.
Who's the person that you recommended to follow for the additional topics? I think you said Adam Mechanic.
Yeah, Adam Mechanic for the parallelism optimization. It's M-A-C-H-A-N-I-C, Mechanic.
And do you recommend max DOP option for index rebuild?
Max DOP option for index rebuild. Yes, absolutely, absolutely. So again, this is part of the optimization you can do with parallelism. If you run large index rebuilds, you have lots of cores on your machine. If you don't use max DOP and the default value is to use all the available cores, then your index rebuild can consume all the CPUs on the server, and it can halt the server. So other sessions have to wait to run even small tasks. So one of the recommendations, yes, is to use max DOP to limit the number of cores that your index rebuild will use and free up resources for other queries running in parallel.
Well, that's it for the questions. I really wanted to thank you again for your time and for an excellent two-part topic, session. This was great.
Thank you very much. Thank you.